a few real-world topics like how much do you end up actually paying if you borrow money for a car, or how much do you end up actually paying if you borrow money for a house. I know we did. Not everybody took Algebra 2 for me last year, though, dude. Of everybody in the room, there was one person who took Algebra 2 from me last year. Yeah. Oh, sorry, there's two people. I'm sorry. Sorry. There's two people who took Algebra 2 from me last year, but like in order to talk about like how much money you actually end up paying if you borrow money from a credit card or whatever, we need to talk about something called exponential growth.
That's why I remember.
No, I know, but we got to lay some groundwork first. So
Foundation.
we're going to talk a little bit about linear growth first, and then we're going to talk a little bit about exponential growth second. So let's talk about linear growth first. So linear growth is super simple.
It's gold.
Great.
No.
So let's say that Steven has 15, I don't know, Xbox games. And gets one game a week.
That's too many games.
So currently Steven has 15 Xbox games and he's getting one game a week. This is called a linear growth because it's growing at a steady pace. It's an exponential growth if there's percentages involved. If it's
20%.
specific amounts involved, though, it's what's called linear growth. So this is linear because there are amounts involved and not percentages. Steven, turn around. Thank you. All right. Now, first we're going to talk about what's called recursive formulas. Recursive formulas versus explicit formulas. Okay, so a recursive, guys, shh, quiet. A recursive formula is where you make a formula where you're saying the amount of games he has is however many games he had before plus something. So a recursive formula would be, okay, so I would say that the amount of games he has is going to be equal to the amount of games he had before, and I'm going to use some what are called subnotes here. So I'm going to say a sub n, which is the amount of games he has now, is going to be equal to the amount of games he had last week plus 1. This is called a recursive formula. So the amount of games he has now is equal to the amount of games he had now minus 1, meaning like a week ago, 1 week before now, plus 1. And this plus 1 is because he's gaining 1 game per week. That's where the plus 1 comes from. Robbie, put your phone away. Okay? Kind of, sort of. Now an explicit formula is going to be based on y equals mx plus b, where the b is going to be however much he starts with, and the m is going to be how much he gains per whatever. So how many games did Steven start with?
50.
So plus 15. And how many games is he getting per week?
I hate that formula.
Okay, this is actually, okay, this is going to be the easiest way to do it though. So, for example, Steven, turn around.
Sorry, that was I hate it.
Okay, shh, quiet, guys. You got to be paying attention right now. This is as simple as it gets. So this is the recursive formula. This is the explicit formula. Now I'm going to ask 2 questions here. Question number 1: how many games? How many games in 3 weeks?
18.
Now, to get that, did you use the recursive formula or the explicit formula?
Neither.
Right. So if you're doing it in your head, honestly, you're really using the recursive formula though, because you're doing 15 plus 1 plus 1 plus 1 or 15 plus 3. Believe it or not, you're using the recursive formula. If you're doing it in your head, you're using the recursive formula. Okay. If you're doing it in your head, you're using the recursive formula. All right. Now.
Will you be able to do it in your head every time?
No. Because I'm going to ask the next question: how many games? I'm going to even go more than that in 200 weeks. Okay.
215 weeks.
200. Okay. So let's sorry. Let's go further. Let's not do 200. Let's do
2 million.
20 years.
Fair enough.
So 52 times 20 plus 15.
Sure.
Attaboy. Dang, you're smart.
So what is it?
A number.
A number?
Right, just.
Am I right? Is that right? I do?
Yeah.
Yeah.
You used your head.
Well, you break it down.
What?
1085.
Okay.
What, James?
All right.
Not games?
So this is linear growth. Okay, shh, guys, quiet for a second. Okay, quiet. This is linear growth. Now let's talk about exponential growth. Exponential growth involves percents instead of involving amounts. So exponential growth would be, let's say that, I can't use Roundup because Roundup's growth has been pretty stagnant. Let's talk about something boring like a savings account. Let's say that we have a savings account. And savings accounts are actually super boring anymore because they gain almost no money. Yeah. Let's
like every for every $100 you got like 5 cents.
So I'm gonna cheat the numbers here. I'm gonna make this unrealistic. Let's say we have a savings account with $100 that gains 10% interest annually, which is completely unrealistic. No savings account in the world does this. 10% interest annually. Do you even know what interest is? Those of you who've had me before, if you've had me, hey, I know that you know. But those of you who haven't had me, do you know what interest is?
Yeah.
Does anybody not know what interest is?
I'm interested.
Great, good pun. Okay. Okay, no, shush. Okay, so let's talk about a recursive formula for finding this, and then an explicit formula. So a recursive formula for using interest means that you would need to do, so we'll call this the amount that you have in the bank account. So you'd have to do the amount times the percent. What is 10% as a decimal?
0.1.
Okay, so the amount times 0.10 plus the amount again. So that would be after, 1 year. Because you'd have to multiply it by 10% to get how much you're adding back onto the original. Okay. Now, that would be only for 1 year. If you want to do it for more than 1 year, you'd have to do, like if you want to do it for 2 years, guys, shh, quiet. This is for only 1 year. If you want to do it for 2 years, you'd have to do this times 0.10 plus whatever all of that was. You'd have to keep doing this again and again and again if you have to do it for more than 1 year. So the recursive formula for this gets really complicated really fast. The explicit formula is A times 1.10 raised to the power of however many years you're looking for, where n is the number of years. Now, you have to use a calculator for this, but this is way easier than doing that, and you can't do either of them in your head. So let me show you an example of this. So let's say that we have this $100, 10% per year. Question number 1, how much in the account
Number of what?
number of years after 1 year? So this is as easy as I could possibly ask. How much is going to be in your savings account after 1 year of this? No? What's 10?
110.
Right, because 10% of 100 is 10, and then you'd add that back onto the 100, so it would be 110%. Okay. Now, question number 2. So the answer to this would be $110. Question number 2 is how much in the account after 20 years. Now, if you wanted to do the recursive formula, here's how you would have to do that. First, you'd have to find out how much is in the account after 1 year. So you'd do 100 times 0.1 plus 100, and you'd get 110. After you get 110, you'd have to do this times 0.1 plus 110. So already we need to break out our calculator. Yeah, and you have to do that every single time if you're using the recursive formula. If you're using the explicit formula, what you would do is 100 times 1.10 raised to the power of 20. And you can do that on every calculator I have. It's not that I don't think that you're right. I'm just going to do it on my calculator up here really quickly. So, because we're dealing with dollars and cents, it'd be $672.75. Now, in this case, would it be easier to do the recursive formula or the explicit formula? Does that make sense? All right. So, let's take a look at our assignment first. You're going to need a calculator. You can use your phone calculator for some of this, but like the iPhone calculator is not built to do this stuff. So you might want to borrow one of mine. Sure.
I know. Don't worry my shirt. Don't look at me, I'm nude. We're not gonna start 8:30. I'm not late. What are you doing? Alright. I'm not doing this.
Whose is it?
Mine.
It does not look like Robbie.
It's RWG.
Okay.
See, look. Hold on.
He's got chicken.
RWG too.
Okay, so question number 1. Phil currently has 40 books, and each week he gets 2 more. To write a recursive formula, you would say that like the number of books he has, a sub n equals a sub n minus 1 plus how many does he get each week? 2. So plus 2. You don't get to choose which one you get to do. Well, you will down here. But like part A asks you to write a recursive formula. Part B asks you to write an explicit formula. Part C asks you to find in 5 weeks and then say if you use recursive formulas. Oh my gosh, I'm the meanest math teacher ever.
Yeah, we know.
So write an explicit formula. Y equals blank x plus blank. How many did he start with? 40 goes here. And how many does he get each week? 2 goes there. That's the explicit formula. So find the number of books he'll have in 5 weeks. So, okay. And Did you use the explicit formula or the recursive formula? Or did you just use your head?
I used
Okay. You used your head, say you used the recursive. So 50. And how many books will we have in 2000?
okay.
Oh yeah, and they didn't go over part E with you guys. We'll go over that right now. Yeah.
I know.
2,000 weeks. It should be 4,040. Because 2,000. So if you put it in here.
Oh, yeah, it's 7 times 2.
Right.
I usually
No, let's do it for D. Yeah. Yep. And then for E, and how many weeks will it eat? You see, 20,000. So all you have to do for E is use the explicit formula. 20,000. 40. Solve for X. You're going to get a decimal or a fraction. Just like whatever what you're like. If you get like 3,825. Just round it to decimal places. So subtract 40 divided by 3.
9,000.
What's your answer?
If you did.
And then for 2 and 3 have the exact same parts A, B, C, D, E. And then, so if you want to flip to the back side really quickly, I'll go through question number 4 with you guys. Okay. So question 2 and 3 have the exact same, bless you, parts A, B, C, D, and E. If you want to flip to the back side really quickly, I'll go through question number 4 with you guys. Yep. Tacoma's population in 2016 was about 200,000 and had been growing by about 9% each year. By the recursive formula. So the recursive formula is that you have to do then equals n minus 1 times 0, 9 minus 1.
I'm alright.
That's the recursive formula.
I know. Alright.
And then the explicit formula would be 200,000 times 1.09 and we're handing the number. And honestly, for me, I would use the explicit formula for both of those. I think the explicit formula is just way easier when you're talking about exponential growth. Like, you can use. Yeah. So if you want to do the explicit, so if you're using one of my scientific calculators here, honestly, I would not use the iPhone's calculator for this, because the iPhone's calculator is a nightmare to do this stuff. Okay. Hey man.
I'm not pro or anything, but it works.
You do you. You do you. Boo boo. All right. So if you're using one of my calculators, I would do 200,000. So 200,000 times 1.09 to the, and if it's 2018, it would be to the second. Yeah. So like on that calculator you're using, yeah. And so my answer for part C was 237,620. And then Part D is asking for the population in 2030. 2030 would be 14 years after 2016. So I'm going to go back. Oops. Yeah. So since you can't like cut people up into pieces, okay,
Thank you.
but they're not going to count for the population.
So
We're going to round
a
to.
paraplegic, does he not count?
No, he counts as a whole person.
Okay.
Or
So
she.
then you can cut him in pieces.
Well, no, they count as an entire person. So we're going to round that to the nearest whole person. So that would be 668,345 people. And that would be your answer for B. And then part 5 is essentially the same thing, just with Portland instead of Tacoma.
Okay.
Okay. And then number 6 is review. All right, so 2 and 3 is just like number 1, which we went through. And then 5 is just like number 4, which we went through. So y'all